Beautiful. Welcome again, ladies and gentlemen, to another for Jackson Securities webinar. Today we're introducing the Ethereum Merge, which is a major crypto event that's been happening recently. It's been developing over the last couple of years from proof of work to proof of stake. And we've got a professional going to be talking to us about the market with Ethereum, and obviously Pratik Kala works for DigitalX as their digital coin analyst and expert there. So we're going to just go through a bit of a presentation, and then we'll go through at the end to answer your questions. So ladies and gentlemen, if you want to just send through your questions, we'll get to those at the end. But Pratik, if you wouldn't mind just hanging off, we'll get into it.
Thanks, Lachlan. Hi all. So as Lachlan mentioned, my name is Pratik Kala. I work at DigitalX as a digital asset investment analyst. So I cover basically all things crypto, you know, from your Bitcoin, Ethereum to coins way down the risk spectrum, and basically looking at whether or not they make sense, you know, what the value proposition is, and how and if we should actually invest in them. So today I'll be talking about the Ethereum merge that happened about a month ago, and it was one of the most pivotal moments in digital assets crypto history. So it's important to know about what that meant and how we got here and what that means for the future of Ethereum and the roadmap of that entire platform. For people who don't know, obviously in digital assets, Bitcoin's king. It takes about 50–60% of the entire market share, but Ethereum's number 2. And there's a lot of development going on in the Ethereum space and all types of experiments that are being done on the Ethereum space, from, you know, your decentralized finance, your NFTs, and a whole bunch of stuff that is being built onto it that generally on Bitcoin that you cannot build. So Ethereum is right up there on the innovation curve and is a rapidly expanding ecosystem. So let's get into it. And today, actually, I've got a very interesting story and a puzzle for you to actually start with. So the agenda for today is an ancient problem, which is a Byzantine generals problem. We're going to talk about proof of work. We're going to talk about proof of stake. We're going to talk about proof of work versus proof of stake. And then we're going to talk about Ethereum, the merge. Now, if you don't understand what proof of work or proof of stake is, don't worry. We'll get into it shortly. And I'm sure whenever you're reading any crypto article, you're going to be listening a lot about proof of work and proof of stake and all of that stuff, which are basically algorithms that are securing these decentralized systems. But let's actually begin with talking about the Byzantine generals problem, which I'm sure is would be very interesting for a lot of you. The Byzantine generals problem was from the Byzantine era and was actually put forward by a military commander or general. And the problem goes as this. So imagine you're a military general. So you are this person here. Imagine you're a military general and you have 3 other battalions, so to speak, and each one of them has their own generals. And your mission is to take over this little castle in the middle over here and take it from an evil king, in essence. Now, there's a problem over here because you guys all your generals are separated by huge distances. So there's no easy way to communicate with them on any sort of attack strategy. Now, one important thing to notice over here is that you would only succeed if all of your generals attack at the same time. So if you attack at different times, you will just suffer heavy casualties and the attack would fail. So the mission over here and the challenge over here is for you as a general to get a message across to each one of your other 3 generals to attack at the same time. And you've decided that the attack should be at dawn. And that's the message that you have to get across. So again, in order to have a successful attack, all of your generals have to attack all together. If either of them are uncoordinated, so if only 2 of you got the message at the same time and the other 2 did not, it would result in a defeat and heavy casualties for your army. So that is generally the Byzantine generals problem. To put it in words, how can we make absolutely sure that multiple entities which are separated by distance are in absolute full agreement before an action is taken? So separated by distance is important over here because obviously if you're just sitting next to me, I could just whisper to you that this is the intention, this is what we have to do. If you're separated by distance, how do you actually communicate and come to an agreement before any action is taken? Or in other words, how can individual parties find a way to guarantee full consensus? Now, for people who don't know what consensus means, it's basically agreement among multiple individual parties. So how can we actually do that? Now, a couple of you might be busy trying to solve the puzzle. You're like, okay, why don't we just have flares? So flares would be used as a signal to the rest of the generals, and we can let them know that, hey, we're going to attack dawn using some flare signaling. However, you'll notice that you can't really use the flares because your enemy is then going to know your intent. Enemy's got to know that they're setting up flares. That means attack is imminent, so they can always bolster their defense, so they could take an evasive strategy before you even get the opportunity to attack. So using flares is not an option. Your second option is to get a bunch of messengers, so 3 messengers going to each one of the 3 generals out there and trying to, with the royal seal, so to speak, send a message that, we should attack at dawn. Now that's a fair strategy as well. However, you cannot guarantee that your messenger is going to reach each one of the 3 generals. So, remember they're separated by distances. They could either be captured or they could be intercepted in a way and bribed or otherwise to actually alter the message. So your generals actually never end up getting the messages for attacking at dawn in sync. So that's one of your messengers actually getting captured. Now this is a second general in one of your 4 general sort of army, and he's got the message that he has to attack at dawn. But you can see his face over here. He's wondering, well, like, how do I know this message is true? Could have been altered by somebody. Somebody could be trying to manipulate or dupe me. So how can I be absolutely sure that it's right? And perhaps there is a general in your army who is going to get that message, and the message says attack at dawn. However, his original intent is to actually retreat at dawn. And remember, if all 4 of you do not attack at the same time, there'll be heavy casualties and the attack would fail. So that actually comes to the conclusion of the Byzantine general's problem on how do you actually get a message across multiple entities, individual parties, get them to acknowledge it, send a message back to you, and then having everybody in consensus that, yes, we are indeed going to attack at dawn. And that's basically you as a general in this example. And then after if you were able to solve the problem, that's when you can sort of give the attack order. Now, throughout history, this is a 1,000-year-old problem, and nobody's actually been able to solve it ever in history. So why am I talking about this? Why is it necessary to, Bitcoin or Ethereum or crypto in general? So let's talk about how this was actually solved. Imagine each one of the 4 generals in this military complex at the moment are actually computer systems. So we've actually replaced them with little PCs over here. And imagine that they're constantly talking to each other at all times, obviously cryptographically locked. So they're following certain algorithms and certain rules, and that they're constantly talking, like there's a millisecond latency between each one of the 4 sort of computers. Now, imagine then that you as a lead computer over here sends a message that attack at dawn, and it gets distributed to all the 4 computers at the same time. Now they receive it and they can either acknowledge it or reject it, right? So in the way the system works is they're all following the same algorithm. So normally if you are the leader node in this situation and you send a message, they would verify your message using some cryptographic smarts and math, and determine that it did indeed come from you and that message is actually accurate, and that we acknowledge it and we are ready to attack at dawn. And that obviously happens in a couple of seconds on a distributed computer network. And that attack at dawn message is sent together. Now the key over here is that all of these ledgers are the same for everybody. So if you've got your 4 generals, in this case 4 computer systems, they are getting second by second live data feeds across whatever it is that you would like to communicate. So these computers are always talking to each other. They have the same copy of the ledger. They can check and double check everything in history since the beginning of whenever the computers started recording this. So each one of them have the same ledger. When a message is sent, it's checked, it's verified with the history, and it's actually then distributed to the rest of the computers on the network. And so all of these computers at any given time are always in consensus and in agreement. and then all of the copies of the ledger are updated to match as soon as these sort of messages are transmitted. So if you're first in the Byzantine generals problem again, the idea is to attack at dawn, and then you were to change it based on some other circumstances that maybe we should attack in the evening instead, then that gets distributed almost immediately. Everybody gets it, everybody acknowledges it, all the computers in the network, and then they're all in sync. And this is what we call a distributed ledger. And the first time that this was ever solved in human history was by Bitcoin and by the unknown founder, Satoshi Nakamoto. So the Byzantine generals problem, to loop back onto that, was never solved in history because humans obviously are varied species. Like, you know, it's hard for any human to know what the intention of the other human is. But with computers, it's easier because it's ultimately ones and zeros, right? So if you can build in the smarts and an algorithm and cryptographically lock certain sets and rules, you can get all of these computers to talk to each other in real time. And if any computer that does not follow set rules, they will then be penalized. And then the algorithm's smart enough to pick up on the fact that you're trying to cheat the system or game the system, because ultimately it boils down to if the equation matches. So if anybody's trying to game the system, the equation will not match, and then they're booted out of the system as a traitor, so to speak, in the Byzantine general sort of situation. And that is what gets us to the proof of work algorithm. So looping back again, we've solved the Byzantine generals problem. We couldn't solve it with humans, but we've solved it with computers. And that is the core innovation that Bitcoin brought into this entire decentralized sort of thesis and the model. It never existed before. We had a whole bunch of computers and databases talking to each other, but there was always a centralized entity that controlled the information flow and could turn off and turn on certain machines. But with the innovation that Bitcoin brought into the market, all of that centralized power has actually disappeared because anybody can join the network and anybody can follow the same algorithm and follow the same rules and always be in consensus at any given time. But how does it work under the hood, right? What is the proof of work algorithm? So proof of work is a decentralized consensus mechanism that requires members of a network to expend effort solving an arbitrary mathematical problem. So a mathematical problem over there is basically the algorithm that you have to check and nobody can game the system. Now, important part over here is it requires a not insignificant but feasible amount of effort in order to deter frivolous and malicious users. Now, imagine in the Byzantine general's army, or generally, if I've got no skin in the game, I've got all intention to game the system. So I can be sending out spam messages, I can be sending out fraudulent messages and basically bringing the network down. However, if as a miner, I have to spend a little bit of electricity, or in some cases, a lot of electricity, in order to be a part of this network, all of a sudden I have a cost to cheat the network. So I have to spend, in some cases, a couple of $1,000s per month if I wanted to attempt to cheat the network. So, you know, that's where you get the barrier to entry, where nobody can just join the network and flood it with, you know, spam messages or so on. So you have to add in a cost factor into it, and the cost is usually energy. So due to proof of work, Bitcoin and other cryptocurrency transactions can be processed peer-to-peer without a need for a trusted third party because they're all following the same algorithm and in consensus at any given time, and everyone's got skin in the game because they're spending a lot of electricity to secure the network. So it requires a huge amounts of energy, and as more miners join the network, the amount of energy increases. Now you might be wondering why this is the case. So round about when Bitcoin started, was trading at 10 cents, $1, $2. Like all of us wish we we bought more back then. But obviously, when it got to $1,000, $2,000, $3,000, there would be certain number of players in the market who said that I'm just going to throw more computers at this and just mine it all before time, like mine all the Bitcoin that exists, and then I'm going to be a millionaire or a billionaire, whatever. However, another core innovation of Satoshi Nakamoto, the creator of Bitcoin, was that if more miners join the network at any given time, it gets harder and harder for this arbitrary mathematical puzzle to be solved in a way. So it's going to get harder and harder to actually solve this arbitrary mathematical puzzle, so people can't game the system and mine more Bitcoin than they should actually mine. And this is a dynamically adjusting sort of difficulty level that adjusts every fortnight. So if more miners sort of come into the network, and you're spending more electricity or whatever, it doesn't mean that you can just mine all the Bitcoin out there, because the network is smart enough. It's like a living, breathing organism in that sense, that it automatically adjusts the difficulty of mining. Now, obviously, the problem with this is people get greedy. People saw the value in Bitcoin. People are like, well, Bitcoin's 60,000 US dollars at a time. So, you know, in Aussie dollars, it was even more. What does that mean? Like, let's just throw more computing power at it and let's try to mine a whole bunch of Bitcoin. And so it obviously started spending a lot of electricity. And that's where we come into this thing called proof of stake. And this is how I would roll it into Ethereum as well. The proof of stake was a new sort of consensus mechanism, or new algorithm, so to speak, which is created as an alternative to proof of work. The reason why is these are the headlines. They're not exactly true, but you'll get the point, where you see Bitcoin consumes more electricity than Argentina. You know, Bitcoin's electricity uses 8 times the amount of electricity of Google, Facebook combined. And then the infamous country rankings, where Bitcoin consumes more electricity than Norway, Switzerland, and so on. Now, this is not entirely true. Like, Bitcoin does consume a lot of electricity, no doubt, but some of these stats are not exactly true. But you see the headlines, like optically, that the proof of work algorithm obviously consumes a lot of electricity, because that was the requirement when the technology came on about 12 years ago, that you have to spend some electricity in order to secure the network. Otherwise, you'd just be defrauding, sending spam messages and so on. That is what the technology was about 12 years ago. Obviously, this is what Bitcoin was, and so was Ethereum. So Ethereum was following the proof of work algorithm. The Bitcoin proof of work algorithm was much harder, so you had to spend a lot more electricity in order to mine Bitcoin. The Ethereum one was slightly easier. You know, you didn't have to spend that much electricity, but you did have to spend still a significant amount of electricity in order to secure this decentralized network. So anybody that is participating in that had to plug it in, and you had to have powerful GPUs and computers that were then mining for these Ether coins, and then that was a method of securing the network. And that was the proof of work algorithm. Obviously, with innovation and with advances in technology, people are like, well, should we really be spending that much electricity for the decentralized network? We get it. We get that decentralization and this entire movement and thesis is correct. It's right. We want to head in that direction. But should we be spending that much electricity? Have we got a better way to do it? And that's when we came to a thing called the proof of stake algorithm, which is what Ethereum transitioned to last month, which was also codenamed the Merge. So what is a proof of stake algorithm, right? The proof of stake algorithm was created as an alternative to the proof of work algorithm. And in this case, you validate block transactions. You validate transactions based on the number of staked coins. So what this actually means is, if I roll back to the servers on the computer network, instead of spending electricity in order to solve this arbitrary math problem so the network can stay secure, what I would do is I'd have to buy a bunch of tokens, in this case Ethereum, set up a computer and lock it in that computer. So basically, algorithmically, I will just lock my tokens there, and I will promise that I will follow the rules of the algorithm. And if I do not follow the rules of the algorithm, you can take all my coins away. So whatever I've set up as you know, as my deposit into the network, so to speak. And that's your skin in the game. Because remember, if we come back to the fact, if you've got no skin in the game, then you're incentivized to spam the network and just take the entire network down. So the skin in the game is you have to pre-buy, you have to buy a bunch of Ethereum, you have to set up a computer to run it, and then that's how you secure the network, and that's how you're an honest player in the ecosystem. For people who are wondering why would I do that? Why should I even bother buying these tokens and doing it? Well, you get an yield on the back of that. So Bitcoin offers a mining reward, which is about 6.25 Bitcoin every 10 minutes. So that's the yield of Bitcoin, so to speak. And Ethereum now offers an yield roughly between 4 to 5% if you promise to secure the network. So you're incentivized to purchase some Ethereum, set up a computer, secure the network, and you're going to get about a 4 to 5% yield paid out in Ethereum, so their own token, every fortnight, basically. So, you know, annualized yield is about 5%.
On that, is there a minimum requirement for the amount of funds that a person or organization needs to have to be staking, or at least have that ability to?
Yep. So the minimum requirements 0.1 Ethereum. But if you wanted to set up your own node and take control of all of it yourself, it is 32 Ethereum. So why did I say the minimum requirement is 0.1? Because there's a thing called delegation. It's like delegation of your shareholding rights in traditional finance. So if I've got 32 Ethereum at the moment is worth about 70, 80 grand Aussie. So not everybody can obviously buy that number of Ethereum and participate in the network in real time. We do it at DigitalX, by the way. But for the regular person that wants to participate in the network and doesn't have 80 grand to throw around, there's a thing called delegation. So you could delegate your coins to a person that is running the server, running the networks, and they take like a 10% fee, and they distribute the rest of the yield, the 5% of the yield. They'll probably keep 10 basis points for themselves and distribute the rest of it to you. So there's another way to do that. And the minimum for that is basically like 0.1 Ethereum, like 20 bucks, 30 bucks, whatever.
Yep.
Yep. And with the transition to the proof of stake Ethereum blockchain, we have basically eliminated the need of spending ridiculous amounts of energy in order to secure the network. Now, that's not to say that that technology was not required in the past. So in 2010, 11, whenever Bitcoin sort of came and became popular, that was the only technology that was out there. How do you bootstrap a new platform and get the token distribution out to sufficient number of miners in the world before you can, to make it fair and equitable, so to speak? The only way you could do it is everyone's got electricity, and this is a computer after all, so everyone has to spend some electricity to be a part of it. So Ethereum obviously followed the same model up until last month, when they've come across that the technology's moved ahead. We don't need to be spending this amount of electricity. We are going to transition to a proof of stake algorithm where people will have skin in the game by actually putting in, setting up servers and locking in a minimum of 32 Ethereum to secure the chain. And with that transition, they have actually reduced electricity consumption by 99.5%.
Wow.
So instead of spending 100 gigawatt hours or whatever, they're only spending like 0.5 now after this transition. So a huge sort of technical achievement and move into that space as well. So here's a little comparison between proof of work versus proof of stake. In proof of work, you've got to solve this asymmetric puzzle. And the reason why you have to solve it is to ensure fairness, that not a single person can game the system. You need specialized equipment and optimized processing power. You have to buy the hardware, and you have to spend a lot of electricity in order to stay within that network, because that's how it was designed. This was Bitcoin and Ethereum, in the past. Now with the merge, with the Ethereum merge, we've transitioned to a proof of stake system, which is now a deterministic selection process. And so now nodes, whoever's participating in the network, by the way, we've got about 200,000 different nodes. Each one of them are then automatically or randomly selected to be the leader at any given time. They all follow the same algorithm. They all then use the same set of rules and basically process transactions and then distribute it to the rest of the network. And then all of them work together to secure this network and get a 5% yield in Ethereum in return. So it takes standard energy consumption, and the initial investment is basically to buy the minimum of 32 Ethereum, or as I said, you can have even 0.1 Ethereum, and you can delegate those tokens to an institutional grade staking provider, so to speak. So we run our own sort of staking node within DigitalX, and then there's many other options if you ever wanted to delegate it outside as well. And that then brings us to the merge and what it was. So you'll see on the left over here, Ethereum prior to the merge was proof of work, and coming back to the proof of work and rotating all the way back to the Byzantine generals problem. How do we get all these computers? How do we get a bunch of different parties to agree on the same thing and be in consensus, so there's no single person who's cheating or defrauding the system, or if we come back to the trader in that Byzantine generals problem where he gets the message that I should attack at dawn, but then decides to retreat anyway. I mean, how do you solve all of these problems? It was a big sort of thing in the game theory where people went like, how do you solve these problems? And computers then came along, but nobody solved the problem until Bitcoin's innovation. And then Ethereum followed in Bitcoin steps. But obviously with time, Ethereum has then decided that we have enough distribution, we have enough network effects, and we should not be spending that much electricity anymore. And we should move to a proof of stake system where skin in the game is by people purchasing and locking in Ethereum on certain computers to secure the network. So it's actually likened. It was a huge event, by the way, for people who are following the industry. It was likened to changing an engine of a jetliner mid-flight, basically.
Yeah, wow.
Yeah, no doubt, because there are 200,000 plus nodes all around the world on a version of a software that are mining all this electricity, using all this electricity, consuming and mining and keeping this network alive. And then all of a sudden you have a snapshot, which was the merge on the 15th of September. And all of a sudden they flip onto and they change into a different algorithm, which then is like greener, 99.95% savings in electricity, and just change in the algorithm. So there was a lot of attention on that because there was many ways to potentially attack the network, that the transition wouldn't happen as smoothly because there's so many moving parts to it. There's DeFi, there's NFTs. There's about several $100 billion worth of assets that are floating around on Ethereum at the moment.
Wow.
So it was, several $100 billion, including several institutions as well, like SocGen in France on Ethereum, and a bunch of other sort of institutional banks are also on Ethereum as well, doing all types of activity there. So, whether or not this transition would happen successfully was a big question mark, but it did happen, went without a hiccup. It was a grand achievement for decentralization. And the merge was basically the transition from the proof of work algorithm, which requires spending a lot of electricity, to a proof of stake algorithm, which is a much more energy efficient, skin in the game, sort of by locking in tokens into a server strategy. And that is how we transition from the journey of the Byzantine generals problem, way back, ancient 1,000-year-old problem, unsolved. Bitcoin solved it. Bitcoin spent a lot of electricity in order to solve it, though. And then Ethereum came along, followed the same footsteps of Bitcoin, spent a lot of electricity. But over time, as we transition, we're like, we shouldn't be spending that much electricity. Let's do the merge, the big merge, save electricity, and make the system more efficient. And that was the merge.
Excellent. Well, we might jump into a few Q&A questions, ladies and gentlemen. You can always just send through the questions down in the tab. There should be a little tab you should be able to send it through. But we did have a few that were sent through earlier on. We had Alex send through a question via email earlier on, saying that after the merge, of course, we have Ethereum's proof of work. Miners will be replaced by staking providers, which will largely be these big crypto exchanges. Now, as we've seen, regulation or censorship from authorities has come into the market a bit more. What does that make Bitcoin the only remaining censorship-resistant blockchain? Is that going to be the same with Ethereum, or what's going to be the case there?
That is a great question. Because that is on the top of everyone's mind after we transition to a proof of stake system. As we've talked through in this presentation, the way that you could be a part of the staking pool is by delegating. So most of the smaller players have just delegated their tokens to the larger players. So you've got cohorts of large institutions that are running these mining pools. And when you've got large institutions running it, obviously somebody can come knock on your door and tell you to comply by certain rules. Otherwise, they'll basically force you to turn your computers off, so to speak. So indeed, after the OFAC sanctions on Tornado Cash that happened about a month ago, there's been a lot of debate within the Ethereum community of what that means. Is that going to force us to be censorship resistant? Are we still censorship resistant? Because the entire point of this decentralization thesis was there would be no central entity that could tell us what to do. Now, in practicality, you can never really be totally censorship resistant in Ethereum until you have control of about 65 or 70% of the nodes. So you would require about 70% of all the Ethereum nodes in the network to be censorship compliant, blocking transactions or whatever, in order for the network to be sort of censored in a way. At the moment, even if the big institutions decide to censor it, I think you're going to cover about 30 to 40% censorship sort of transactions, so to speak. And the reason why I say it is because remember how the algorithm works. It basically takes your transaction, and then the leader is decided randomly, and then the leader then distributes the transactions to everybody else in the network, and the other network just follow the rules. And as long as it's all right and humming along, like consistent with the history, they will just accept the transaction. So let's say I send a transaction and it goes to, for example, Coinbase that is running a validator service, and they're compliant, and they reject my transaction. Fair enough, the transaction's sitting in the memory pool, right? So it's going to be retried. My transaction's going to be retried. And let's say it goes to Coinbase again, they reject it again. Let's say it goes to Coinbase again for the third time, they reject it again. But just with the passage of time, eventually it will go to another server running in another part of the world that has decided not to comply with the OFAC sanctions, so to speak. And so that transaction will eventually get processed. So it's just a matter of delayed transaction processing, but that transaction will effectively get processed. Now, I'm not obviously supporting that idea that we should be processing transactions that should otherwise be illegal and stuff, but in theory, it's extremely difficult to censor a network like that, just like it's difficult to censor the internet. You can block certain websites and stuff, but people are smart. You got VPNs. I mean, you got satellite internet now with Elon Musk's Starlink. So you can't completely block it out at all, unless you get 60 to 70% of the network to agree, which may happen. But at the moment, there's a strong fight back on, privacy and all of that stuff as well. So we'll see how it plays out.
Absolutely. We've got another question here from Mark. He said, previously with Ethereum, you used to have gas prices. Now, are they disappeared, or are they no more, or is there still going to be these gas prices, as they say?
There's still going to be gas prices. So the merge was basically a transition from proof of work to stake. Everything else remains the same. You're still going to have to pay gas. And gas prices are still going to be as high. So gas prices are dynamic. The more the people use the network gets congested. And then so it's a dynamic, it's like Uber surge pricing in a way. More people want to use a limited amount of resources, the gas prices sort of goes up. So right now gas prices are cheap, but they haven't gone away. Now Ethereum's long-term roadmap, which is another 2.5 years it's going to take to build out the rest of the infrastructure. That's when gas prices and stuff will come down significantly. They're using roll-ups and sharding and all that type of stuff. But gas prices are still there. You still have to pay gas. And the reason for gas, for anybody wondering, is because imagine I had no gas at all. I didn't have to pay any fee. So you could have a Russian, North Korean, Chinese hacker or an adverse party, so to speak, and if they want to bring the network down, they can just spam the network because it's free. But the reason why you charge a gas is because you need to ensure that there's a cost to attacking a network, and so you can only attack it for so long before you have to give up because you're going to run out of money in a way.
Yeah, excellent. We've only got a few more questions here, but I've been hearing, this is from Nigel, I've been hearing a bit about central bank digital coins. Recently, the Digital Finance CRC introduced that they might be using Ethereum as one of their pilots. Is there any comments that you could be making on that?
Yeah, I'm not involved in that project or process. I read about that, so I can't comment exactly on what the Treasury or the Digital Finance CRC is doing. Whether they're using Ethereum. Now, Ethereum has different types. There's a permissioned Ethereum, so there's a private Ethereum, so to speak, which enterprises, like, they've taken the software and they've privatized it in a way. There's one of that, and then there's obviously the public blockchain as well. I'm aware of many central banks coming up with CBDCs over time, and some of them are going through the private route, some of them are going through the public route. I know Norway's central bank is also trying to do a proof of concept on Ethereum. Now, what level do they want to be on public versus private networks is to be seen. The benefits of CBDCs obviously are, well, you basically get rid of any sort of money laundering, tax evasion, or anything else like that, because everything's there, it's visible, it's public, and the algorithm is checking every move. So imagine if at birth you were born and you were given a wallet, sort of dystopian as well, but you're given a wallet and everything is sort of checked by the algorithm, every single transaction. And the moment something fishy, like if you get a credit of whatever, something out of the normal bounds, then it gets flagged like in a second, not like in 3 or 6 months when a royal commission or something gets set, but like in a second. So I mean, I think eventually that's, that could be the goal of CBDCs. What technology they'll use, to be seen, but Ethereum no doubt is the dominant sort of platform that a lot of these trials are being made on. Bitcoin, for example, you cannot do any of these experiments on that because Bitcoin is not a smart contract platform. Bitcoin's very simple. It's got the store value thesis, limited supply. You spend electricity, decentralized, first that ever existed, solve the Byzantine generals problem, but you can't build a CBDC or anything else on Bitcoin.
Yep, absolutely. No, perfect. Our final question is from Sandeep. He asks, how many nodes are currently out there in the network, and overall, what's the cost going to be if there's multiple more?
The cost is flat. I think there are over 200,000 different nodes if you were to, depending on how you calculate it. So they're pools, and then the pools have subnodes, but they're about 200,000 different nodes out there for Ethereum. The cost is going to be flat. Like, you could have more nodes joining the network. All you got to pay is for the hardware, for the computer, and then your 32 Ethereum stake, so to speak. So the cost is absolutely flat. The thing that changes is the yield. So because the network has to be dynamic, right? If you've got a whole number of people, a whole bunch of people that are joining the network, your 5% yield is not going to be 5% anymore. Your 5% yield is then going to sort of like, there's a bonding curve, or there's a curve in a way. It then drops off to like 4%, 3.5 or 3.6% or something. And then again, this curve is very smart in the sense that if more people join, the inflation rate goes down. But if the same people turn off their computers and they're like, I'm getting out of the network, then the inflation rate sort of goes up. So it's a dynamic sort of curve to incentivize people to come in. But if people try to game the system and just throw more computing power and get a whole bunch of nodes in, then the inflation rate sort of goes down. And this is basic classic game theory, because if you're going to incentivize people in a certain way, there's always going to be somebody who's trying to try and game the system by, adverse incentives. So you got to have this dynamic inflation schedule, so to speak, so as to keep this decentralized network alive. Because in the centralized world, I mean, you just go to the court, or you knock on somebody's door and you say, hey, you got to turn off that database, or you got to reverse these transactions, and that can happen. But in a decentralized world, you got to have the right set of incentives in place to ensure that not too many people game the system, but the network is sort of a living, breathing thing as well, and people want to participate in it as well. So it's a fine balance, and it's been going pretty well so far.
Absolutely, absolutely. Well, it looks very exciting for the future. I'd like to thank Pratik on the behalf of Port Jackson Securities for doing the presentation and answering our questions today. Do you have any final comments or anything you want to say?
Well, the final comments is, I hope you've taken something out of this, and you've seen that how Bitcoin solved the Byzantine generals problem, and how decentralization is basically solving some of the problems that are out there. It's going to be exciting times in the future. There's obviously, we are very pro-regulation as well. Obviously, these decentralized networks sort of started, and then they evolved, and over time now they're a big beast as well. And we don't see a world where there's not going to be any regulation at all, and these are going to be allowed to function as they are at the moment. We're obviously, we're looking at regulations from all around the world, from the European Union, from the States. Australia is working on a token mapping exercise as well. So over time, the space is going to evolve, and I think we're going to find a good balance between the right level of decentralization, so a central entity cannot control and take away your assets or data or history or whatever. But at the same time, it's going to be compliant with regulations in some shape or form. It's an exciting space, and it's an ever-evolving space, and there's a lot more things to come around, such as zero-knowledge proofs and sort of identity zero-knowledge proofs as well. So big case in point at the moment is with the Optus data breach. I think if we already had zero-knowledge proofs, which were live at the moment, that sort of data breach would have never happened. Obviously, this is early technology still. It'll take a couple of years to get proven out, but keep an eye out because this is definitely going to be Web3 as a whole, and this entire space is going to grow. And over the next decade or 2 decades, you're going to see some large sort of disruptive sort of technologies come out of here and append existing business models. So yeah, keep an eye out.
Absolutely. Perfect. Well, thank you so much for coming on today. Thank you, ladies and gentlemen, for attending another Port Jackson Securities webinar. We look forward to seeing the next one, and Pratik, we'll have to do another one. We'll have to get you on board again and discuss about a few other cryptos maybe in the future. But apart from that, I'd like to thank DigitalX and Pratik today for taking their time out. And apart from that, we'll see you in the next one. Thank you very much, everyone.
Thanks, Lachlan. Bye.
Thank you. Bye.